Hey, so like now we are just maturing into real data science domain. We have seen about Julia, and now we then we just saw about some machine learning concepts, and now what we are going to do is a very good data science stuff. This is called as feature engineering, right? So let me tell you what is it. Okay. So before that, I just want to ask, what is the most important job of a professional? Like, uh, so, like, so, what do you think is the most important job of a professional? Just think about it. I feel like important job of a professional is what to say to solve the problems of people who pay him. For example, politicians, like we pay them via tax and they need to solve our problems, right? So that's the thing. Our boss has some problems. He wants some money and all those stuff. So yeah, we need to solve his problems and we earn him money. So we give him money anyway. So by doing work and he must solve our problems. Okay. So that's the thing. That's what professionalism is. Okay. So similarly, even data science, it's just like any other job, just like a person in the street who picks garbage so that he gets money. He gets money by what to say, removing our trash from our vicinity. So uh, a data scientist is as great as a garbage picker. What to say, like they both are professionals, right? So that's the thing, right? No profession is less or no profession is great. Okay, so that's the thing. But how do you solve problems, right? First, you need to understand the problem, right? So, like for example, like let me take this garbage picker itself, right? He knows that okay, like what is waste for us is useful to somebody else, or it might be useful to us indirectly. Like for example, a thrown out glass bottle could be remolten and formed into a new glass bottle once again. Like no problem about that. Okay, so he knows that. So you need to understand about the problem and only then you can think about solving it. And I do want to add a note, for example, like employers over here. So to understand about a problem and to solve it takes time, right? In many data science projects I don't see that, right? So like if you're a employer employing some data scientists to do some projects, and if you're in a very tight budget, maybe what you're doing is wrong, right? So what to say, a person who needs to solve problems need to have time, he needs to have peace of mind and all those stuff. So yeah, so why I'm talking all these things, like why go to philosophy in when I want to talk about feature engineering. Okay, feature engineering is a very important step in data science and it is for solving problems. So let's see how it's been done. Okay, so okay, yeah, I'll link all these sheets in this video. So you have a sheet called Feature Engineering Titanic Dataset, right? So that's the thing. And so over here, I'm just first importing like data frames and CSV. So yes, and I'm loading this file like Titanic CSV. So if you look at Titanic CSV, so this is the thing, right? So that's the thing. And okay, yeah, there are a lot of missing values. Look, here it's missing. Okay, like age and this row 29 looks missing, right? And over here, cabin is missing a lot and all those stuff. So yeah, now I'm just kind of understanding the stuff. Look, cabin is missing, age is sometimes missing, and all those stuff, right? And we know that in Titanic analysis when we did it, right? So we loaded this data set and we dropped all those missings and okay, this is feature engineer and okay, this is the thing. Okay, so we load the Titanic data set. Okay, and we drop all the missing things. We got only 183 rows out of 891. So that is a very low yield. So how to get a higher yield? Okay, so one thing is like okay, like we saw here, right? This cabin has a lot of missing. So okay, so let us think more about it. Okay, our duty is to predict whether a person has survived or not. Okay, right? So that's what to say, a column that has lot of missing values aid in prediction? I don't think so. I think you can drop it. Okay, so you can drop most of these things, and that's the thing. So yeah, now we are just trying to understand the data set, right? So like that is the thing. So we can drop this data set. Okay, so here I've just put like, okay, a P class and cabin, and I've just seen. I thought there will be a lot of cabin class missing values also, but no. Almost everybody's class seems to be documented, but the cabin is missing. The reason why I think is like, okay, like yeah, the second and third class and all, it's like a dormitory. You just go and stay over there. There is no concept of rooms or something like that. They were no, it wasn't much. There wasn't much privacy. It was just like travel for them. Okay, for the first class, yeah, it was like a luxury cruise or something like that. Okay, so you can see the class difference and all those stuff. So you can also understand the society at that time, right? So yeah, understanding is part of data science, right? So now we just look at what are all the column names. Okay, that's the passenger ID. Do we need it? Okay, look, this passenger ID is just a serial number given. Okay, it could be, you can't say anything from it, so we can take it out. Okay, survived, yeah, we need, because we need to predict, right? So survived we need. Passenger class, is that needed? Is this related to survival? Anyway, okay, I did see this Titanic movie, and looks like what to say, like they logged the third class and second class and all this stuff. Mostly only the first class people survive. Okay, so I feel like, okay, the class is important. Okay, name, is this important for survival? Okay, I don't think so. The captain didn't say like only person with name John should aboard a boat or something like that. Person with any name can aboard a boat. Okay. Is there sex or gender important? I think yes, because the captain said women and children first. Women means, yeah, it's their gender, and the men were just men should have the bravery to die at that time. So that's the thing, right? So yeah, and is age important? Yes, the captain said women and children. Children means, it doesn't mean that it's boy or girl, right? Everyone are children, right? So less age people should have survived more. Okay, so okay, and I understood the data set. SIBSP means how many siblings and spouse you had, like on the ship. That is like if you went with your brother and what to say, sister, SIBSP will be 2. Okay, so that's the thing. Is that important? I don't think so. They didn't have any mandate saying that, okay, like siblings and all, like what to say, if you have 2 siblings, you can aboard a boat. If you have none, you shouldn't, or something like that. I don't think so. Okay. PR is, I think, like it's number of children. I just think. Okay, so that's the thing, and so that's the thing, and I think that's important because what to say, like I think, yeah, these are all important features. Okay, yeah, I have cataloged the important features over here. Sorry. So it's the number of children, I just think. Okay, so like parent or children. Parent or children, yeah. That's what I think PR means. Okay, yeah. Because I just read it hours ago. So that's the thing. Okay, so yeah, whether you had parent or children. Okay, so whether your mother or dad is traveling along with you in Titanic. Okay, so I don't think like, okay, if a 20 years old man traveled with his mother and father, that mattered. But let's say a woman with a child, okay, traveled. Maybe that would have mattered. I don't know whether it would have, what to say, contributed to one survival. But if you see a woman with child, yeah, you will definitely give them some room, and you will, what to say, give them a better chance of survival. Like I'm sure, like everybody has that soft corner for children, and especially women with children. Okay, so that's the thing, right? So yeah, so these are all the columns that are important. Okay, so and so yeah, I think we have kind of feature engineered, even though we may not be Titanic expert, but with our knowledge, and of course this knowledge was accumulated through history. Okay, we read a lot about Titanic, saw movies about it, talked about it, and when I was young, it was even in my school's education, right? So there is a lot of history, but in real sense, in real time, if a client gives you a data set and he just says do feature engineering, like mostly you won't have any idea. So you need to consult domain expert, and people need to give you domain expert to do stuff properly. Okay. So yeah, that's how it is. Okay. So yeah. So without domain experts and all, if somebody tells you to do, I don't think so. Like, so that won't work. Okay. So now what we are doing is like we are just doing this drop missing of the original data set. Okay. So DF, and we only get like 183 rows. Out of those 800 plus rows, we are only getting 183. Okay, so 891 rows, nearly 900 rows, we are only getting 183. So very low yield if you put drop missing. Okay, so now what we are doing is like we are creating a data frame with important features. So these features are nothing but this one, right? This features you have, right? Like so, this features. This value we just take and we just put. So we'll only get all these columns. So IP, class, X, age, and PR. Okay, so that's the thing, right? And I don't think PR is important, but yeah, anyway, like anyway, leave it. So yeah, I will just include it. But I'm in a dilemma. Like, so that's the thing, right? And now yeah, we'll just do the first DF important features, and yeah, looks like we have got 5 columns, 1, 2, 3, 4, 5, right? Sometimes if the column name is long and there are a lot of columns, data frames truncates it. So don't think okay, like all data frames are very little or something like that. Open that file, okay, like open this file and see for yourself, see with your own eye, right? So that's the thing, right? Only if it's really big, open with data frames, and it has got way to handle stuff and all those things, right? Okay, right, okay. So now what we are just doing is like, okay, like we are taking this data frames of important features and only, okay, looks like, okay, I just have an intuitive feeling like, okay, but anyway, I just checked before this video. Not much is missing in it, right? So that's the thing. And I'm just putting like size of DF important features. Okay, so yeah, it's still 891 rows. Okay, now I'm just doing this drop missing over here, right? And before, if you did drop missing, you've got only like 183 rows or something like that. So I'm very sure about that. So 183, where is it? Where is it? Where is it? Where is it? Yeah, if you do this, you got only 183 rows. Okay, but look, now since we have selected only few columns and all those things that are very important and all those things, we have reduced this drop missing, right? So that's the thing. And look at the yield we got. Before we got only like 183, and now we have got 714. So that's 531 rows more. And if you put it in percentage, like it is, what to say, 290 percentage. That is like 2.9 times yield than this, the first thing what you did in drop missing, the previous video. So that is a very, very huge gain, I just feel. And yeah, and next, how to store. Okay, now we have done this very important transformation in this CSV. There should be a way to store it, right? So that like you can't keep going on and just working with just RAM. Like you need to do some operations, store it, then okay, think about what you have done. Okay, take that stored value and do another operation, and so on and so forth. This is actually called as data pipelining. It will be automated in real systems, but yeah, now you are learning data science. It's manual now. Yeah, we will construct an automated data pipeline. Why not? Like we will do that, and just for fun, we'll just do that and see. So in that, something will take, okay, and it will only select the necessary features, drop the missing, and finally store it. So that's the thing. So yeah, that's how it will do the data pipelining. Over here we can store it, and we use a CSV library, and we use a function called write. Okay, so we use a function called write, and we just give the file name where it needs to be stored, right? So and we just give this data frame that needs to be stored. So this will be stored as CSV. Okay, and it's been stored in this Titanic feature engineer.csv. So in this data folder, okay, there is a data folder over here. You can see there is a data folder, Titanic feature engineer. Okay, so look over here, the missing is there. Like look, you can see some missing in age. I'm not saying no, but the thing is, like look, it's far more less. Okay, so and we will deduce some very important stuff over here. Look, how many are missing just over here, like in this cabin. Just look, 1, 2, 3, 4, 5. Just I can just keep on counting the number of missing values over here. It's sparse. It's actually what is missing. Missing is there, but it's sparse. Okay, so that's how it is, and we'll see what we can do with this data set in future videos. We'll see like what is the gain we got, and we'll do entropy analysis with this, and we will come to a stunning finding. Okay, so that's the thing. I hope you enjoyed this video, and I hope like you understood what feature engineering is. It's very very important thing. Feature engineering books have been written. So if you want, yeah, like Amazon.com. Okay, like I'll just go to .com because that has more books than .in, right? Okay, so feature engineering. Okay, it has even books written. Like, look, feature engineering. I think this is a famous book. Okay, and it costs $42. Okay, look. Oh, and I just kind of compress this entire book into 10 or 15 minute video. Okay, so that's the thing. Okay, but I shouldn't claim that. Okay, so look, this might kind of cover a lot of cases, right? So, which I haven't covered. So, like, look, I shouldn't be what to say saying those things, but there are books written on this feature engineering, and it's such an important topic. Okay, and that's the thing. The reason why we go to neural network is, okay, neural network is very good at picking the features. Okay, so but the only thing is like it doesn't work with small amount of data. It needs large amount of data, but it's very very good at picking features. So whereas ML algorithms or other ML algorithms, you need to cherry pick features by yourself and use it. Then why do both exist? Okay, places where there is a lot of data and you need less manual intervention, you give it to neural networks. Okay, a place where there's little amount of data but still you need to learn something, you let humans clean and analyze the data. You pick the right features and you'll give it to a ML algorithms. Okay, so that's how it works. Okay, so that's why we need both of them. We have situation of less data and more data. And if you see, if you even looked into our previous videos and all those things, in the iris data set, okay, like let me just show it to you, like where is this iris? Okay. Is there any way to search for file over here? IRIS. Okay, fine. This is actually okay. In iris data analysis, if you see, why this looks like this one? Okay, yeah. I'll just restart kernel and run all cells. Okay. I don't know why it's taking so long, but yeah, it'll take long. But yeah, if this runs and finishes, you can just see the previous video in this playlist. Like you would have seen that. Okay, like just by plotting, we could just solve it. Manually, we could just solve it. Okay, with our own eye and okay, this is using packages and all those things. Okay. So I think this is going to take a lot of time, right? Okay, yeah, I shouldn't have done this. Okay, right. Yeah, okay, I think it has run. Okay, it's saying it's long. Okay, yeah. So it's going. Okay, and why did I do this? I could have done this one. Okay, data science with Julia. So yeah, I should have done the efficient one. Here it's okay. So yeah. So if you just plot it, right? With this itself, you can say like 4.8 above 4.8 means it is virginica. From 2.5 to 4.8, you can say it's it's versicolor, and below 2.5 you can say it as setosa. Like, and sometimes you don't even need ML. Most of the cases for data scientists you don't need ML, right? And 95% you don't need ML, and rest 5% out of it you need ML for something, and with lots of data you usually go for neural networks and all those stuff. So that's the thing, right? So yeah, this also ran. Okay, yeah, anyway, so that's the thing. So yeah, that's how it is. So your main thing is to analyze problems, and to solve your payer's problem or employer's problem. Okay, that's the thing. And for that, you need to understand the problem, and you need to understand the right features and pick them up and give it to a ML algorithm. Okay, so that it works more efficient. Okay, so that's the thing. So yeah, feature engineering is important. Please keep that in mind, and understanding the problem is important. Communication is important. So keep that in mind. Okay, so anyway, yeah, thanks for watching this video. I hope you enjoyed it and you have understood it. So yeah, subscribe, like this video if you want. So anyway, thanks for watching.